When we think of black holes, we usually imagine destruction, unstoppable monsters that tear apart anything that gets too close. Stars, planets, even light itself, swallowed whole by a gravity so strong that nothing can escape. But what if we've been thinking about black holes all wrong? Instead of being cosmic death traps, black holes might actually be the greatest power sources in the entire universe. Forget solar panels or nuclear reactors. A single black hole could outshine them all in terms of raw, extractable energy. In fact, some scientists believe that if we had the right technology and nerves of steel, we could tap into black holes' rotation, radiation, or magnetic fields to power entire civilizations. Not just for decades or centuries, but for millions, even billions of years. It sounds like science fiction, but the physics behind it is very real. And if we ever hope to reach the level of Type 2 or Type 3 civilization, learning how to harness the raw fury of a black hole might not just be an option, it could be a necessity. Today we are diving into the incredible science behind one of the most mind-bending ideas humanity has ever dreamed of. Could we ever actually harness the power of a black hole? Black holes aren't just powerful because they devour everything around them. They are powerful because they concentrate an insane amount of energy into a small region of space, and that energy doesn't just sit quietly. First, there is the gravitational energy. A black hole's gravity is so intense that anything falling toward it gains incredible amounts of kinetic energy. Matter doesn't just drift in, it spirals at near light speeds, crushing and heating up into an accretion disk, so hot it emits radiation thousands of times more powerful than anything our sun produces. In fact, the area around an actively feeding black hole can outshine an entire galaxy. We call these quasars, the brightest objects in the universe, and they are powered by black holes eating matter and spitting out energy. Then there is rotational energy. Some black holes spin, and when they do, they drag every fabric of space-time around with them. This spin stores enormous amounts of energy that in theory can be extracted using clever physics. We'll get to that soon. Finally, there is Hawking radiation, a theoretical process where black holes very slowly evaporate over time by emitting particles. Although tiny for large black holes, this evaporation process hints that black holes aren't just one-way doors. They can lose energy too. In terms of efficiency, black holes are absolute monsters. While nuclear fusion, the process powering stars, converts about 0.7% of mass into energy, a black hole's accretion disk can convert up to 40% of infalling matter's mass into pure energy. That's not just powerful, that's cosmic level efficient. And if black holes are massive batteries, the question is, how could we tap into them without being destroyed? Surprisingly, real physicists have proposed a few mind-bending methods. First, there is the Penrose process, proposed by physicist Roger Penrose in 1969. It works like this. If you send an object into an ergosphere, the region just outside the rotating black hole, you can split it into two pieces. One piece falls into the black hole, while the other escapes, with more energy than the original object had. You're stealing rotational energy from black hole itself. In theory, a civilization could repeatedly use this method to extract enormous amounts of usable energy without ever crossing the event horizon. Another method is the Blandford-Znaiec process. Instead of throwing objects into the ergosphere, this technique would involve powerful magnetic fields threading through the black hole's spin. Those fields could extract rotational energy and channel it outward, creating beams of radiation or plasma jets that could be harvested. Astrophysicists believe this might already happen naturally around supermassive black holes in the centers of galaxies. Then there is the idea of simply tapping into the accretion disk. As matter spirals inward, it heats up and emits staggering amounts of energy, mainly X-rays and gamma rays. If you could build structures close enough without being vaporized, you could harvest that radiation directly, like capturing the blast of a star, times 1,000. Each method sounds extreme, and it is. But according to the laws of physics, all of them are theoretically possible. The real challenge isn't whether it could be done, the challenge is surviving long enough to pull it off. And when we talk about engineering on that scale, we start entering a territory that sounds even crazier. If harvesting energy from a black hole sounds wild, building a Dyson sphere around one, that takes another level. Traditionally, a Dyson sphere is imagined as a colossal structure surrounding a star, capturing most or all of its energy output. But some futurists and physicists have proposed even a more ambitious idea. What if an advanced civilization built one around a black hole instead? Here is how it might work. Rather than a solid shell, which would collapse under its own gravity, you would construct a Dyson swarm, a vast orbiting cloud of energy collectors positioned at a safe distance from the black hole. These collectors would absorb radiation from the accretion disk, jets, and even Hawking radiation, converting them into usable power. There are some surprising advantages. Black holes can generate way more energy per unit mass than stars, especially if they're actively feeding. And because black holes exist for billions or even trillions of years, a civilization could have a near-eternal power source. Of course, the engineering challenges are almost unimaginable. You would have to resist immense tidal forces, survive intense radiation, and maintain stable orbits near an object that bends space and time itself. Still, if a civilization advanced enough on the Kardashev scale were looking for ultimate energy efficiency, black holes could be the crown jewel of their cosmic infrastructure. It's a wild idea, but the universe has a way of turning wild ideas into reality. Before we dive into just how insanely difficult building something like this would be, if you're loving these mind-bending ideas about the future of space and technology, make sure to hit that like button and subscribe for more journeys into the strangest and most ambitious possibilities in the universe. And if you had a chance, would you try to harvest energy from a black hole? Drop your answers in the comments, I'd love to hear how bold you be. Dreaming about harvesting black holes' energy is one thing. Actually doing it is another. First, there is the obvious, gravity. A black hole's gravitational pull is so extreme that even small miscalculations would result in your collectors being torn apart or crushed into oblivion. Operating close enough to gather energy, but far enough to avoid destruction, would require precision on a level we can't even imagine today. Then there is radiation. The area around an active black hole isn't just bright. It's a storm of deadly X-rays, gamma rays, and relativistic jets traveling near the speed of light. Building any kind of structure that could survive that constant, high-energy bombardment would require materials far beyond anything we have now. Maybe even technologies we haven't yet dreamed of. You would also have to deal with the relativistic time effect. Close to a black hole, time slows down dramatically. For energy harvesters operating near the event horizon, time could pass at a different rate than for the civilization further away, creating huge synchronization problems. And if you're trying to manage orbiting collectors or massive magnetic fields near the agrosphere, tidal forces, the stretching and squeezing caused by differences in gravitational pull, would constantly threaten to rip everything apart. In short, theoretically possible? Yes. Practically achievable today? Absolutely not. But just because something seems impossible now, doesn't mean it will stay impossible forever. And who knows, somewhere out there an advanced civilization might already have figured it out. If harnessing the power of a black hole sounds extreme, it's worth asking a bigger question. What if someone out there has already done it? According to the Kardashev scale, a method of measuring civilization's technological advancement based on energy use, a Type 2 civilization would be able to control the energy output of an entire star. A Type 3 civilization would command the energy of an entire galaxy. For a civilization operating at that level, tapping into a black hole wouldn't just be an interesting idea, it might be essential. Black holes offer dense, efficient, long-lasting sources of energy, potentially lasting trillions of years. For an advanced society looking for sustainable power on cosmic timescales, black holes could be the ultimate prize. Some scientists have even speculated that if civilizations are using black holes to hide their energy use, or to operate on scales we can't even detect, it could help explain the Fermi paradox, the question of why we haven't seen signs of intelligent life yet. Maybe advanced civilizations don't build giant beacons or flashy structures. Maybe they build dark, efficient, hidden infrastructures around black holes, working quietly, siphoning energy invisible to primitive species like ours. It's pure speculation, of course, but if physics allows it and survival demands it, then somewhere in the vast darkness of space, maybe someone has already mastered the art of black hole engineering. And maybe one day we will too. Black holes have always captured our imagination, as terrifying destroyers, cosmic mysteries, and now as potential power sources for future civilizations. The idea that we could one day tap into the raw fury of a black hole sounds like pure science fiction. But the truth is, the physics behind it is real. Processes like the Penrose mechanism, magnetic field extraction, and accretion disk harvesting aren't just fantasy. They are written into the math that governs our universe. Of course, the engineering challenges are staggering. We are nowhere near ready to build orbiting energy collectors near a black hole or survive the tidal forces and radiation storms swirling around them. But then again, 1,000 years ago, we couldn't imagine rockets, satellites, or even electricity. Dreaming about harvesting the energy of black holes pushes the boundaries of human imagination, and that's exactly what great science does. It reminds us that the universe isn't just something to fear. It's something to understand, to explore, and maybe one day to master. Because if black holes hold the keys to the ultimate energy source, then maybe, just maybe, our future lies not in running from these cosmic giants, but in learning how to work with them. Thank you for watching. Keep looking up.